Hey there, we're going to finish up our section on trigonometry in the coordinate plane, and in this video we're going to focus on how you can find the gradient of a line passing through the origin given the angle that that line forms with one of the axes, preferably the positive x-axis, but we can work with any axis we want to. Okay, now let's talk about how you use trig ratios for gradients or for slopes. Whenever we're talking about gradients, you guys know that rise over run is how you find the gradient of a line. Okay, now so we're going to be finding the gradients of lines specifically that pass through the origin, and so you can see that this line does indeed pass through the origin. I drew the unit circle also so that we can discuss some relationships there that are going to happen. But let me go ahead and start off by writing this equation here. We know that slope equals rise over run. And you can make that ratio between rise and run using any 2 points that are on the line. And in this case, what I'm going to do is I'm going to choose to use the origin, and I'm going to choose to use one of the points where that line intersects the unit circle. All right. And I want to do that because we can kind of write the rise and run in a different way if we do so. Now, let me draw a right triangle here. You know I can draw a right triangle by connecting directly to the x-axis and then, well, drawing over. And since this is a unit circle right here, that would mean that the vertical distance, or the rise, is equal to the sine of theta, where theta is the angle that our line forms with the positive x-axis. And the y-coordinate, or the run, in this case, would be cosine of theta. So does this make sense how the slope then would be equal to the sine of theta over the cosine of theta? Very good. One more relationship I want to make right here. If I told you to find the tangent of theta, this seems random, but I'll connect it real easily. If I asked you what the tangent of theta was equal to within that triangle, you would be making a ratio between the opposite leg and the adjacent leg, wouldn't you? Can you see how the tangent of theta then would just be equal to sine of theta divided by cosine of theta? Now that's an example of what's called a trigonometric identity, and it's one that you're going to have to know well. Always you can find the tangent of an angle by making a ratio out of the sines and cosines of that angle. And the reason I wanted to bring that up here is that we can simplify this expression even a little bit more. You can find the gradient of a line that goes through the origin by using the angle that it forms with the positive x-axis by dividing the sine of that angle by the cosine of that angle, or you can say that the slope is equal to the tangent of that angle. Okay, so here's the formula that we're going to be using, really kind of both of these things, in order to find out what the gradient of a line passing through the origin is. Now let's just see a couple of examples with that. Let's say I wanted to find the equation of this line that you see right there. Well, of course, whenever we're writing the equation of a line, typically we write the gradient intercept form, the y equals mx plus c form, but since we're talking about lines that pass through the origin, the y-intercept is 0, isn't it? So we don't need to worry about the plus c or plus b, whatever you're used to calling it. So we can just write y equals mx, meaning that the only thing that we need to know in order to write the equation of that line is we need to know what its gradient is equal to. All right, now if we use what I just said a moment ago on the previous picture, we know that if we know the angle that this line forms with the positive x-axis, and think of it being in the center position, we can just use the tangent of that angle to find out what the gradient is. And so in this case, that would be 110 degrees. You see where I'm getting 110 degrees from? So we could say that the equation of this line would be y equals the tangent of 110 degrees times x. Very simple, right? And then typically what you'll do is you'll round the gradient, you'll change it to a decimal and round it to 3 significant figures, which would give us here y is equal to negative 2.75x. which makes sense, right? This is definitely a negatively sloped line, and you can see the tangent then gave us the correct sine, everything that we needed to do. That's how you write the equation of a line that passes through the origin using angles. All right, one more example, and the information I'm giving to you is a little bit different. This time, I'm telling you the line passes through a particular point. So I haven't given you the angle that it forms with the x-axis, but I didn't have to either. All right, because it turns out one of the things that we can do is we can just calculate what that angle is. You're going to find it a couple of ways we can do this, but I want to tie this into the angles. We could find the angle theta that this line forms with the x-axis in a couple different ways. We can use the cosine inverse and apply that to the x-coordinate. All right, I can say theta equals the cosine inverse of 0.242, or we could say that theta equals the sine inverse of the y-coordinate. So the sine inverse of 0.970, or we could say that theta equals the tangent inverse of 0.970 divided by 0.242, right? Okay, no matter which of those you choose to use, you're going to find that theta is approximately 76.0 degrees. Okay? So then the equation of the line, we could say, is y equals the tangent of 76.0 degrees times x, which then is equal to, or approximately anyway, 3.99x. All right, you see how that works? Now, in this case, we simply could have just done 0.970 divided by 0.242. Would have given us basically the same thing, but I'm trying to tie this into trig ratios. All right, great. Thanks for your attention, everybody. And, well, good luck with all this stuff. See ya.